Can using the wrong charger damage my device? Hi everyone, Leo Notenboom here for askleo.com. Here's a summary question, something that I get very often. I have a charger that has these characteristics, and I have a device I want to plug into that charger with these requirements. Will the charger damage my device? Now, unfortunately, that is almost an unanswerable question. There are so many different chargers and so many different devices with so many characteristics and so many levels of quality that I can't give you a one-size-fits-all yes or no, even when you give me all the characteristics. What I can do is I can offer you some guidelines. Some combinations are pretty much guaranteed to work just fine, and some put you at a high risk of failure. And of course, there are some scenarios in which, well, we just don't know what's going to happen. Okay, let's start with USB. If the charger and the device you're looking at are based on USB, then there's really not much to worry about. It's extremely unlikely that any USB-based charger will damage a USB-based device. More often than not, it'll just work. That's one of the beauties of USB. Now, on one extreme, if your charger is more powerful than your device, the device will just charge or run normally. The charger might be overkill, but it won't harm anything. At the other extreme, if the charger is underpowered compared to the device, then the device might charge or run more slowly, not charge at all, running will continue to drain the battery, though perhaps more slowly, or complain. Complaining happens with laptops, actually, that use USB-C as their power and charging source. For example, if you take your phone's little USB charger and attempt to use it as the primary power for your laptop, yeah, the laptop's probably going to complain that there's not enough power. But with USB, damage just isn't likely, no matter what you do. Now, when we step away from USB connections, there's a wide range of connectors with different shapes and sizes and characteristics. The single most important characteristic is polarity. Of the two wires in that charging cable, one is going to be positive and one is going to be negative. It's very similar to your car. The battery has a positive and a negative connection. Connect things backwards and in your car you could see fireworks and be looking at a costly repair. Sparks and flames are rare when computer chargers are connected improperly, but damage is not. Perhaps the fastest and most likely way to damage a device is to connect it to a power supply or charger with the wrong polarity. Now, exactly what polarity your device needs and what's provided by the charger you have in hand can vary. Somewhere there should be an indicator. For example, a barrel connector has a connection inside, often just a pin, and a connection on the outside, typically a ring or a metal sheath. One will be a positive connection and the other negative. In this image, the pin in the center is shown as either positive or negative, with the barrel being the opposite. You'll typically find these polarity indicators on chargers and often, not always, on the device you're charging. If it's not there, if you don't find it, you'll need to find it elsewhere, such as in the product documentation. These must match. Your device and the charger you plan to plug into it must have the same polarity. No exceptions. Now, next up is voltage. That power supply is going to provide electricity at a certain voltage. Common voltages are 5 volts or 12 volts or 24 volts and many others. The device you're connecting to usually expects a certain specific voltage. Thus, the voltage provided by the power supply and the voltage expected by your device should match. Now, if the power supply provides a higher voltage than the device expects, it may damage the device. If the power supply provides the correct voltage, well, all is well. If the power supply provides a voltage lower than the device expects, it's unlikely to damage the device, but it's also unlikely to work. Where we run into problems and the unanswerable question is when we consider how different a voltage can be and still work. For example, if your device expects 12 volts and your power supply or charger provides 12.1, is that a problem? I can only say probably not. It depends on the tolerance and the quality of the device in question. What if the charger provides 13 volts or 18 volts or 24 volts? There's no way to answer that in general. There are devices that expect 12 volts that will tolerate all of those and more. There are devices that will fail if the voltages are different by any of those amounts. In many cases, if the voltage is sufficiently different, particularly if the voltage of the charger is higher than what's expected, then yes, the device could be damaged. Not as important for damage are amps or watts. If the voltage is correct, the amperage provided by your power supply or charger is almost guaranteed not to damage your device. By the way, watts equals volts times amps. So if you have a 65 watt power supply that's providing 12 volts, well, divide 65 by 12 and you end up with 5.4 roughly amps. If the amperage provided by the power supply is lower than the device needs, the device will charge or run slower or not at all. There is a small chance that a poorly designed power supply might overheat. If the amperage provided meets the device needs, all's well. If the amperage rating of the power supply is higher than what the device needs, all is well. The device will use only what it needs. When it comes to damage, amperage ratings are typically the least of our worries. When replacing a power supply or charger, do your best to match your device's needs. That means matching the voltage as closely as possible and making sure that the power supply has the amperage rating that meets or exceeds the device's needs. Unfortunately, if something is even a little bit off, we can't rule out damage. At that point, it comes down to the characteristics and quality of the specific power supply and the specific device that are involved. For updates, for comments, for links to related articles and more, visit askleo.com/175274. I'm Leo Notenboom, and this is askleo.com. Thanks for watching.